Hello all. Previously we have seen variables in C language. Now in this particular video we will see constants in C language. Constants in C language are variables, but the values of the constant variables cannot be changed during the execution of the program. Variable value might change during the execution of the program, but when it comes to constant value, once it is declared and once it is initialized, the value of the constant variable cannot be changed. That is the difference between variable and constant. Let us see how we can declare constants in C language. We have two different ways. The first one is using const keyword. With the help of a keyword called const, we can declare the constants in C language. So example, const space int space abc, that is the variable name abc, is equal to 100. This 100 we cannot change later onwards. Okay. And second one is const space float space x is equal to 25.2, and this value cannot be changed later. Once it is fixed, that is rock written, we cannot change it. And the second one is using hash defined directive. These are called symbolic constants, but usually when it comes to symbolic constants we will use capital letters to denote the variable names. These variables should be written in capital letters. You should not terminate symbolic constants with semicolon. Here when it comes to const keywords we are terminating with semicolon, but when it comes to symbolic constants we are not terminating with the semicolon. Enough of theory. Let's see practically in code. Now in this code I have declared symbolic constant and as well as constants. That means by using const keyword also I have declared some constants. Let us see how these are different. On line number 2 I have declared hash define. The variable name is pi and the value is 3.14. This is called symbolic constant, but the symbolic constants have a global scope. I will tell you what global scope means in a while. And on line number 5 I am declaring one simple function, sample function, void means nothing. This function cannot return anything. This function won't return anything. That is the meaning of void, and the name of the function is sample, and this is called function declaration. This is called a function declaration. If you can understand it, or else we will see definitely in functions topic. In that you will definitely understand what is function declaration, and what is function definition, and what is function call. We will discuss these terms in functions topic. If you can understand, well and good, or else don't worry. On line number 6 we are writing main function. The compiler starts from main function only. On line number 8 we are declaring one constant of integer a is equal to 10. See here we are terminating the constants, the const keywords with semicolon, but when it comes to symbolic constants we are not terminating. That is the one point you should remember. And printf, constant a value is, and this particular a is integer type, right? So the format specifier is %d, and this value should be referred in a variable, and 10 will be displayed onto the output screen. On line number 10 we are printing constant pi value by using %.2f format specifier. That means after decimal point only I want only two places. That is the meaning of this highlighted code here. And the format specifier should the value should be referred from the variable pi, and 3.14 will be displayed onto the output screen. So in the line number 11 I am calling one function called a sample. This sample is already defined. I mean this sample is already declared on the line number 5. This is called a function call. On line number 11 we are calling sample function. So we are going to sample function, that is 14, 15, 16, 17 lines. This is called function definition. This is also in subprogram section. As you already might have studied in structure of C program, this is a subprogram section. So printf, we are in sample function, we are in sample, but the pi value is %.2f. So pi value can be accessible. This hash defined symbolic constants have global scope. Global scope means this particular pi value can be accessed throughout this file, but this constant int value cannot have the global scope. But the constant int a is a local scope to main. Within local scope, within the main function only we can use this particular a. Outside main function we cannot able to use that. That is the local scope and this is the global scope. So symbolic constants have the global scope, and the constants which are declared by the const keyword are having the local scope. These points you should remember. Now let us try to run this code. Let's see the output. The constant a value is 10, the constant pi value is 3.14. We are in the sample and the pi value is 3.14. Now let us try to access that particular a, whatever you are seeing, and whatever you are seeing at line number 8. Now I am trying to access that particular variable in sample function. Now let us see how this works. So a value is percentage d. This should be referred in a variable called a. You will get a compilation error because that constant variable has local scope. Here a is not visible here, that is why a is undeclared. Like that you will get an error. Now let us try to run this code. Execute, compile and run. You got the compilation error saying that a is undeclared. Okay, here I am not seeing a value. Okay, that is the difference of scoping. There are different types of constants. One is numeric constants and another one is character constants. Numeric constants further divided into integer constants and real floating constants, of which integer constants are further divided into decimal, octal, hexadecimal and binary. When it comes to character constants, we have three different character constants are there. One is single character, another one is string constant, and another one is backslash constants. We will see one by one in upcoming slide. Now let's see the decimal constants. In decimal constants, only 0 to 9 numbers are allowed. We can store positive numbers or negative numbers in as part of decimal constants. Decimal constants should not start with 0, because if you start with 0, that number is treated as octal constant, not the decimal constant. That the point you should remember. We have different types of examples as part of decimal constants over here. Const space int b is equal to 249, which is a correct decimal, and const int is equal to c is equal to minus 321. We can store negative numbers as well as positive numbers, right? So this is also correct. When it comes to const int d is equal to 0 240, it is not a correct decimal. This is treated as octal, not the decimal constant. The next type of constants are octal constants. In octal constants, only 0 to 7 numbers are allowed. It should be start with 0, and the examples are listed down below. Const space int space b is equal to 024. This is a correct octal. And the next one is 001. This is also correct octal. When it comes to third example, 078 is given, but 8 is not there in octal numbers. 8 is a not valid number in the octal constants. So you will get a compilation error in octal constants. The format specifier for octal constants is percentage %O. The next type of constants are binary constants. In binary constants, only 2 digits are allowed. It is 0 and 1. It should start with a 0 small b or 0 capital B. Let's see some examples so that we can understand binary constants. So const space int a is equal to 0b. That means we have to prefix with 0b, and then we can give the zeros or ones. So 1 1 1 1. That means 15 in decimal. This is a correct binary constant. And const int b is equal to 0b 1010. This is 10. 10 in decimal. Const int c is equal to 0b 107. 7 is not valid binary value, so it will throw an error here. So these are some binary constants. The next type of constants are hexadecimal constants. In hexadecimal, we can have 0 to 9, small a to small f, and capital A to capital F. These are the valid digits can be allowed as part of hexadecimal constants. It should start or it should prefix with 0 capital X or 0 small x. So let's see some examples. So const int b is equal to 0x249. This is a valid hexadecimal. Then const int c is equal to 0x321. This is also valid hexadecimal. Const int b is equal to 0xbef. Const int b is equal to 0xbeef. These are valid hexadecimal values, so it is allowed. On line number 4 or the fourth example, const int e is equal to 0xbear. R is not valid hexadecimal value, so this is not valid. The next type of numeric constants are real real or floating constants. We can store floating or double point values in floating constants. That means 0 to 9 and dot can be allowed as part of real or floating constants. It can be positive or negative. Let's see some examples to understand it better. Const float a is equal to 24.56. It is allowed. Const double is equal to double b is equal to 56.78. This is also valid floating constants. Enough of theory. Let's see numeric constants practically in C code. Now let's see all numeric constants with the example of C code. On line number 5, I am declaring a variable called a with the type of integer and it is a constant, so that the value of the constant cannot be changed later onwards. So I am declaring 249 here. That means a decimal constant, and the decimal constants cannot start with 0. If you start with 0, that particular constant will be treated as octal constant. So keep this in mind. On line number 6, I am printing that particular decimal constant value. So 249 will get printed onto the output screen. On line number 9, I am declaring one variable called b, which is of type integer and it is a constant, and I am prefixing with 0. That means if you prefix with 0, that particular constant is octal constant. So this cannot be treated as decimal number. This can be treated as octal number. So on the line number 10, I am printing octal constant directly by the use of format specifier of percentage %o, and this percentage %o is referred in b, and in b024 octal will be there. That value will directly print onto the screen. That means 24 will get printed as part of this line. On line number 11, I am printing the corresponding decimal value of 24, and that format specifier is percentage %d, and that percentage d will be referred in b. In the b we have stored 024, right, and it will be converted to decimal point number and it will be displayed. On line number 3, I am declaring one variable called c, and I am prefixing with 0x. That means it is a hexadecimal number. In hexadecimal constants, the allowed digits are 0 to 9 and small a to small f and capital A to capital F, and this is a valid hexadecimal literal, and I am printing hexadecimal constant value by the using of format specifier percentage %x. So this will be referred in variable c, and 0x249 will be displayed. That means 249 will be displayed onto the output screen. On line number 15, we are converting hexadecimal to decimal, and that corresponding percentage %d and that corresponding integer value or decimal value will be displayed onto the output screen. The next constants are binary constants. Binary constants can be prefixed with 0 small b or 0 capital B. The only allowed digits in binary are 0 to 0 comma 1, and I am declaring one variable called d is equal to 0b 4 ones. That means if you convert this 4 ones, it is a 15 in decimal. I am printing that value. Binary constant decimal value is percentage %d, and that particular 15 will be displayed onto the output screen. The next and final numeric constants are real or floating constants. As part of real or floating constant, we can store float numbers or as well as double numbers as well. Const float e is equal to 249.4f, and double f is equal to 321.56. For float, the format specifier is percentage %f. For double, the format specifier is percentage %l, that means small lf, and that will be referred in variable f. I will compile and run this program for you, and see here binary constant decimal value is 15. The other values are displayed accordingly. The next type of constants are character constants. Character constants are further divided into 3 parts. The first one is single character constants, the second one is string constants, the third one is backslash constants. Let's see single character constants. In single character constants, only one single alphanumeric symbol can be saved in characters, and it should be enclosed in single quotes. Let's see some examples. Const char c is equal to, in single quotes I have stored backslash. Const char c is equal to, in single quotes I have stored digit 1. Const char d is equal to, in single quotes I have stored capital A. So these are the some examples of single character constants. The format specifier for character is percentage %c. The next type of character constants are string constants. It consists of sequence of characters or group of characters which are enclosed in double quotes. Previously we have seen character constants where we have enclosed in single quotes, but when it comes to string constants we are enclosing in double quotes. Let's see some examples. Const space char space b, and we have a one array symbol. This is called an array. Arrays are usually denoted by square brackets and is equal to, we are storing in double quotes Sri. Sri will be get stored in B array. Don't worry about arrays. String is an array of characters. Arrays we will discuss in future lessons. So on line number 2, const char C array is equal to, in double quotes we are storing C programming. This C programming string will be stored in the C array. Similarly, we have D array is equal to, in double quotes we have 1 2 3. This 1 2 3 will get stored in D array. Don't worry about arrays. Arrays will be discussed in further lectures. The format specifier for string constants is %s. The next type of character constants are backslash constants. These are the special sequences of characters which are used to represent non-printable characters like new line, tab or carriage return, etc. How you can print new line as part of programming? We cannot write. For this purpose they have introduced backslash constants. If we follow these particular backslash characters, those particular functionality will be happening in our program. So backslash constants are starting with the backslash symbol. These are called backslash constants. These are part of character constants only. Examples of backslash characters are includes slash n. This is a new line. That means the cursor will be moved to next line. Slash t, that means horizontal tab. The cursor will move to some spaces. Usually tab means 4 spaces or 6 spaces depending on the computer architecture. A tab space might vary. Slash b, that means backspace. One character will be removed from the current line. Slash r means carriage return. Slash a means audible bell. If you want to print a single quote, you can use a backslash quote, that will be printing a single quote. If you want to print double quote as a character, you should use backslash and followed by double quote. And if you want to print question mark as part of the string, you should use backslash and question mark. And these are the some examples of backslash characters, of which we will use mostly new line and horizontal tab. Null value, there is a one concept called null value. We will be using mostly these only. Null value will be used in string constants. The string terminator is null value, by the way. Don't worry, we will see in strings. These are some examples of backslash characters, and the format specified for these constants are if you use %d or %i, it will print a decimal constant. If you print %o, it's an o, not a 0. It will print octal constant. %x means it will print hexadecimal constant. %f comma %lf to print floating constants, that means float or double. %c means to represent character constants. %s means to represent string constants. That's it for constants. We will see you in next lecture. Thank you so much.